All right, welcome to Notes 15-1. We are on page 209 in the book, logarithms and their functions, logarithmic functions, and their graphs. And so today we're going to use composition to verify two functions are inverses, define the logarithm of y with base b, and write the inverse properties of logarithms. Now you have the coolest teacher on the planet, the best teacher on the planet, because I already did this with you guys. So these notes should be pretty easy. All right. It says you've investigated the exponential functions with a base of 10 and their inverse functions, the common logarithmic function. Recall that the Richter scale situation, g of x equals 10 to the x, where x is the magnitude of the earthquake. The inverse of that function, m of x equals log x, where x is the ground motion compared to the magnitude. As part of each of the graphs, a part of each of the graphs, g of x and m of x, is shown below. What is the line of symmetry between the graphs? How does that line compare with the line of symmetry in item 3? So I don't know where item 3 is. Let's flip over to item 3. We'll have to compare it later because we haven't gotten to it yet. So, okay, I don't know about this last part of the question, but we're just going to skip over that. So right here, the line of symmetry is right there, the line y equals x, right? And that is always true of inverse functions. So y equals x is the line of symmetry. This is always true for inverse functions. Okay. All right, so it says logarithms with other bases than 10 have the same properties. And I've already actually given you this for this definition. This is the definition of a log. I also say, hey, this is when we use the hook method, right, to change from a log into an exponential function or vice versa. It says the exponential y equals b to the x, the exponential function, and the log function y equals log base b of x are where b is greater than 0 and b cannot equal 1 are inverse functions. The restricted domain of one function is the restricted range of the other function. Likewise, the restricted range of one function is the restricted domain of the other function. And it says because the range of an exponential function is restricted to positive numbers, the domain of log functions is restricted to positive numbers. I want us to think about that, the range, the y values of an exponential function. So for example, if you have y equals b to the x power, if b is a positive number, which it says b is a positive number, there's no way that y will ever be negative. If you raise b to the 0 power, you're just going to get 1. If you raise b to a negative, you'll get a fraction. If you raise b to a positive, you'll just get a larger number. So this will always be positive, right? The range is always positive. So therefore, in its inverse function, which would be log base b to the, I have to think, guys, just a second, to the y equals x, yes, that's right. This function, the range, or sorry, the domain, which is your x values, are always positive. Okay. All right, so it says let g of x equal f inverse x, the inverse function of x. Write the rule for each function write the rule for g for each function given below. All right, so first I'm going to rewrite it as y equals. So this goes back to the steps for finding inverses. Number 1, write f of x as is y, right? Number 2, switch x with y. And number 3, solve for y. Okay, those were our steps for finding the inverse function. So again, we already did this on the board. So y equals 5 to the x, and then I'm going to switch x with y. And I can't really solve for y here, but this is my inverse function. So similarly, right, we're going to rewrite this as y equals log 2 of x. And then I'm going to rewrite this as an exponential function. I don't know how to write this without that. Oh, I think they just want us to switch x with y. So x equals log 2y. And finally, the last one, y equals log ex. Now, e is a value. We'll talk about e a little bit more later, but e is about 2.1. I think it's 2.16. It might be 2.18. I have to look again, but it's a value like pi. It's just a number that occurs naturally. And so then we switch x with y. And there we go. Now, if we wanted, I don't think they want us to write these as exponential functions, but if we needed to write them as exponential functions, we could. All right. So it says to examine the function f of x equals 2 to the x and its inverse, g of x equals log base 2 of x. Complete the table of data for f of x equals 2 to the x. Then use those data to complete the table for log. All right, so we're going to substitute in, right? We're just substituting in these values. So f of negative 2 is 2 to the negative 2. 2 to the negative 2. Remember, this does not make the value negative. This becomes 1 over 2 to the 2, and that would be 1 over 4. So this is 1 over 4. F of negative 1 is 2 to the negative 1, which is 1 over 2, or 1/2. F of 0 is 2 to the 0, which is 1. And then f of 1 is 2 to the first, which is 2. And then f of 2 is 2 to the second, which is 4. All right. So now, since they've told us these are inverse functions, and guys, I'm going to verify that. Let's take a look at these functions and see why are these inverse functions. So here we have y equals 2 to the x power. Remember that we would change this in order to find the inverse function, we would switch x with y and solve for y. Well, we wouldn't be able to solve for y here, but I will switch x with y. And I get x equals 2 to the y power. Again, I haven't learned how to solve that yet. I do know how, but you haven't learned. And so my inverse function would be this function, right? So these, this is like f of x, and this is like f inverse x. Now we're going to rewrite this as a log using the hook method. So remember, it's log of the base is 2, log 2, 2 equals, right, x. So log 2 of x equals the exponent. The exponent is y. Again, using the hook method, also known as the definition of an inverse, or definition of a log. So 2 to the y equals x. That's true. Verify it to yourself. And look, that is our inverse function right here. Boom. That is the inverse function. All right. So now that I have verified for you that these are indeed inverses, this is all I did was verify that they were inverse functions. Now we know that in an inverse function from the original function, the domain and ranges switch. So this is going to be my domain, and this is going to be my range. All right, so my domain will be 1/4, 1/2, 1, 2, and 4, and my range will be -2, -1, 0, 1, and 2. Again, you could check that by using this function right here, right? The exponential form. These are equivalent. Remember, these are the same functions. Now, because I don't know how to graph this or how to substitute values into this, but I do know how to substitute values into this. If I were to choose values for y, so again, I'm just verifying that this is truly our inverse function. If I take this function, x equals 2 to the y, which these are the same thing, guys, and I plug in these values for y, I get x equals 2 to the negative 2. 2 to the negative 2 is 1 over 2 squared, which is 1 over 4. Oh, boom, look, there's my x. And then if I do x equals 2 to the negative 1, I get x equals 1 over 2. Boom, there's my x. All right. And again, the reason we're plugging them in for y is because we would not know how to plug in values for x here and get out a y without using a lot of common, like, logical reasoning. Okay, so describe how the values in the table illustrate the fact that they are inverse functions and explain your reasoning. We're actually going to skip that. I just did a bunch of that off to the side, guys, and I just did it right here as well. All right.